Hey everyone, welcome back to this analog video series. In this video, I'll talk about inverting and non-inverting amplifiers. Amplification is probably one of the most common uses for op amps. It's in the name, operational amplifier. Real-world signals like the ECG from your heart or the output of a microphone, they don't come preconditioned, right? Usually they're pretty tiny, they've got some noise, all sorts of stuff. And one of the first things we want to do is amplify the signal so that it fits within the full scale range of your ADC. So how do you build an amplifier? If you were following along with my previous videos about voltage followers, you'll have a pretty easy time of setting up an amplifier. All you really need to do is put a voltage divider in the feedback network. So let's do that now. We'll put a resistor right here, and we'll put a resistor right here. So the interesting thing about inverting and non-inverting amplifiers is the schematics are identical actually. The only difference is where you put your input signal. So for a non-inverting amplifier, you put your signal here at the non-inverting pin. That makes sense. For the inverting amplifier, you put your input signal here at this resistor. So let's talk about the non-inverting amplifier first. So the gain of the non-inverting amplifier is going to be this R1 divided by R2 plus 1. So in this case, let's say this is 2K and this is 1K. Then the gain of this circuit here will be 2 divided by 1 plus 1. So the gain will be 3. So let's test that out. What do we do with this thing here though? First, we need to just give it a DC offset voltage. So let's just put it in the middle of our power supply voltage, so just 2.5 volts. And push OK. And what should we set our input signal to? Let's just have it be a sine wave, 2.5 volts. We want to keep it within the dynamic range. So if it were an amplitude of 1 volt for the sine wave, and our gain is 3, that would push us outside of the dynamic range. So let's say 0.5 volts. That should be good. And let's make sure our transient analysis has enough time. So let's push run. Okay. So it looks like our amplifier is doing what it should. So we have our 0.5 volt amplitude sine wave, input sine wave here. And so it should go up by 0.5 volt, so 2.5 to 3 volts. This should go up by 1.5 volts, right? 0.5 volts times 3 is 1.5. So this should go up to 4 volts. And it looks like it does. So that looks good. Okay, so now you might be saying, well, didn't you say that putting a voltage here at this resistor is going to turn it into an inverting amplifier? Well, yeah. So when you have a non-inverting amplifier, you actually also get an inverting amplifier as well, and they're kind of fighting against each other. So let's talk about inverting amplifiers, and then we'll analyze the whole circuit together. So the gain of an inverting amplifier is negative R1 divided by R2. So the gain that this non-inverting, or the gain of this inverting amplifier sees is negative 2. So let's look at the whole circuit here. So we have an inverting amplifier and a non-inverting amplifier. We can kind of add the two together. So let's look at DC first. So the DC gain the DC that we see here is 2.5 volts times minus 2. So we've got negative 5 volts here. And then the DC that we see here is 2.5 volts times 3. That's the gain of this non-inverting amplifier. So we get 7.5 volts. We have minus 5 volts. So we add them together. We get a 2.5 volt DC offset at the output. And that's what we get here. As for the AC, there's no AC signal at the inverting side. So we really are only looking at the AC signal from the non-inverting pin. And that's just a non-inverting amplifier that we had looked at earlier. Okay, what if we switch the two? So we make the non-inverting side be DC and the inverting side be where our signal is. So let's just turn this into a DC signal of 2.5 volts. And then our inverting side can be our sine wave with an offset of 2.5 volts. We'll do this. and the peak can be at 1 volt, and because that will keep us within the dynamic range. We'll see. All right, let's give that a shot. Okay, so we see this this negative gain of our inverting amplifier here. It starts going low instead of high like the non-inverting amplifier was. Let's check out our gain. So 2 volts, 1 volt times -2 should give us -2 from our 2.5 volt DC. So it should go down to 0.5 volt, and that's what we're seeing down here. So this looks good. That looks like our inverting amplifier working the way that it should. And if we did the same analysis like we did earlier, you can do that on your own and figure out how to add the 2 non-inverting and inverting amplifiers together. So when should you use the non-inverting amplifier versus the inverting amplifier? How do you choose which one to use? One thing you need to think about is the input impedance of your amplifier. The input impedance of the non-inverting amplifier is massive, right? It's the input impedance of your op amp, basically. But the input impedance of the inverting amplifier is R2, so much smaller usually, but also adjustable. So maybe you want to be able to choose what the input impedance is of your amplifier. The other thing you need to think about is the inverting amplifier has a phase shift of 180 degrees, right? The gain is negative, so you're going to get this. It's going to go down first instead of going up. So you need to think about that too. So that's about it. If you want to learn more about op amps, check out the other videos in this series. Thanks for watching.